Hey, welcome back to our data structure and algorithm. Today we are going to discuss how to find height of the binary tree. That's our task. So think that we have this binary tree node. We are going to find height of this tree. Just by looking at the tree, we can say the height of the tree is 30 because this is one edge and this is one edge. So 2. Height of the tree is 2. But programmatically, this is the code which will find out the height of the tree. So what we are doing here, so we are just finding a root element height of the left subtree and height of the right subtree, and we are going to compare which one is bigger, and we are going to add one, and we are going to send the height. So that's the simple logic to find height of the tree. Since it's a very recursive function, so it's really important to understand how the stack grows strings when a control visits each node. Okay, that's the motto of this presentation. When someone calls the height of the tree method with the root element 30, the call stack at very beginning, the call stack is going to look like this. So we are passing root node 30, and the left height, right height, and height is 0, since it's a local variable which is declared inside height of tree. So the same value will appear in the call stack as well. Next, when we the root node, when we check against root equal to null, no, it's not null, then this line of the code is going to execute height of the tree, and we are passing root left. Okay, this is the root and we are passing this node. Now how does it going to look like the call stack in this case? Okay, so we have 25 root node, and left height, right height, and height is 0. That's fine. What next? Now again it's going to check root equal to null for this particular node. No, it's not null. Again it's going to call height of the tree root dot left. The root dot left of 25 is null, but it's going to push that root equals to null. Okay, remaining or 0. If root equal to null, we are going to return -1. So what happens? So it's going to return -1 to left height, because this is the function which was keep on calling. Okay, then it's going to return left height equal to -1. Now we are going to find, is there any right subtree for node 25, right? So let's call again it's a null for the right subtree, so it's going to return -1 back to this guy, and the right height is going to be -1. Yeah. Now we are going to check these two guys, left height and right height. Okay, which one is bigger? In this case, this portion is going to execute -1 plus 1, and the height is going to be 0. That's what height is going to be 0. Okay, when this function returns 25, returns value, okay, 0 back to 30. 30 is left height is going to be 0. Now we have done analyzing the left subtree of root node 30. We are going to analyze find the height of right subtree of the root node. Okay, so the control is going to execute now this particular line of code. Okay, and we are passing root dot right. Now the root node is 30, 30 is right is 50. Okay, and we are pushing this to call stack. Whenever we call, the stack frame is going to be pushed to stack. So now root points to node 50, and left, right, and height, both these three variables are assigned to 0, and we are going to check whether the root element is null. No, it's not null because it's holding node 50. Okay, then it comes to this line of the code, height of the tree root dot left. Root dot left is again it's another node, we have 5, which is going to be pushed to the stack. Okay, now root is pointing to 5, and again we are going to check root against null or not. No, then we are going to push the left node of left child of 5. Okay, here in this case left child of 5 is null. Okay, then we are going to check against root equal to null. Yes, then we are going to return -1. Okay, the right child of 5, okay, is going to no, left child of 5, because we are going to find left child of 5, left height is going to be -1. Now we are going to find, is there any right subtree for 5? Okay, let's check. No, there is no. Then the right child is going to be -1. -1 -1, height is equal to 0. Okay, now when 5 returns, the right height, left height of 50 is going to be 0. Okay, and 50 is going to find, is there any right subtree? Okay, 50 is going to find, is there any right subtree? Okay, it's going to push the right element, right child. Since there is no right child for 50, it's going to be null, and we know what will happen now, because we have seen a couple of times this scenario. And it's going to return a right child to -1. Okay, now the 50 is going to calculate the height of its subtree. It's 1, because left height is 0, right height is -1. Which one is bigger? Left height is bigger, and we are going to add left height plus 1, that's going to be 1. Okay, then we return this guy back to root node 1. Okay, left height here is 0, right height is 1, and we are going to calculate right height plus 1 equal to 2, and it's going to have 2. This is the value which we are going to return to the caller, whoever called. That's it. Thanks for watching.